Okay, all right. So in this class, we are going to talk about some past paper questions just so we get to practice the concept. But before that, I would like to spend a few minutes on the overview of whatever we studied yesterday. Okay. So we know what exactly binomial expansion is, and we have practiced the questions from this topic as well. That is done. This is the new thing. Right. So basically, we have two types of sequences, arithmetic sequence and geometric sequence, and you can also call a sequence a progression. Okay. If the examiner wants you to find any specific term, or if we talk about the nth term formula basically is a plus n minus 1 into d. This formula is basically for arithmetic progression, only for arithmetic progression. A plus n minus 1 into d, where a was the first term, d is the common difference, and n is the number of terms that you are finding. Okay. Then we just use this formula. We'll use this in past papers now. Next, we discuss the sum of an arithmetic progression formula. So here, basically, imagine you have a sequence and it's going on, and the examiner wants you to add all the terms till the 100th term or till the 50th term or till the 60th term. So you can't just add the terms like this. This would take a lot of time. So we use this formula, right? You can either use this formula or this formula. This totally depends upon the question or the situation you are in at that time. The formula is n divided by 2 into 2a plus n minus 1 into t. N is the number of term till which you're adding, a is the first term, and d is the common difference. Okay. And then the second formula is a plus l. So everything is same except this l. L is basically the last term. Okay. Then we use this formula, and let's forget that. At उसके बाद we discussed geometric progression. Now in arithmetic progression, we were able to notice that every term basically had every term was being added by a number, and then we were able to find the next number. So the difference between two consecutive terms was common. The difference was common, right? In case of geometric progression, we have a common ratio. So I would have to multiply something with the first term in order to get the second one. And then same number would be multiplied by the second term in order to get the third one. So in geometric progression, we have a common ratio. We are multiplying something, and in arithmetic progression, we were adding or subtracting something. Okay. The nth term formula in case of geometric progression is basically a into r power n minus 1. A is the first term, R is the fixed ratio, that is 3. 3, 3 in this case, it would be same because it's common ratio, right? And then we have n minus 1. Similarly, just like arithmetic progression, the next thing is the sum formula. So if let's say if you have a geometric sequence and you have been asked to add the first 100 terms, you are going to use this formula. A is the first term, R is the common ratio, N is the number of terms that you are adding. Okay. And then this was a bit different. Next concept was a bit different. Now again, you have a geometric progression, but if you notice the previous one, what was happening in the previous one? Our terms were increasing. The first term was 1 by 9, then 1 by 3, then 1, 3, 9, 27, then 27 multiplied by 3, and so on. The terms were increasing. And the last term, like if you have infinite many terms means a lot of terms, right? A lot of terms. The last term is going to be infinity because we do not have any point to stop. We are multiplying every term by 3, so the last term is going to be infinity, right? So this is a case where we use this sum formula, right? The examiner would give you a specific number and you will have to add terms for that number only. But if you look at this sequence, first one is 2, 1, 1 by 2, 1 by 4. My terms are reducing. And if I go on continuously, like if I again write down infinite many terms, this basically means infinite terms. I know that the last term is going to be very, very small because gradually my denominator is increasing. My denominator is increasing. So by the end of infinite many terms, my denominator is going to be infinity. And 1 divided by infinity or 1 divided by something very, very big is approximately 0, right? So in this case, we certainly can add all the terms. So this basically means sum till infinity. And what is the formula? It's a divided by 1 minus r. A is the first term, r is the common ratio. And always remember, this formula is only applicable if your r is between -1 and 1. Basically, r has to be a fraction that is greater than -1 and less than 1. It could be -1/2, it could be +1/2, that does not matter, but it has to be a fraction where the magnitude is less than 1. So in that case, you can use this formula. And obviously, if the examiner would ask for sum till infinity, he's only going to ask if this is the case, right? He would not ask you to find the sum till infinity if your ratio was 2 and every number was increasing. That is not possible, okay? All right, that is it. So any confusions from this? This is something that we have already discussed in the previous class.
No, miss.
Okay, Munja, any questions from you?
No, ma'am. Thank you.
Okay, you're welcome. Let me just share the other PDF. Okay, now we need to talk about some past paper questions. Okay, because we are clear with the ideas and everything. And now we need to see how exactly are we going to use this knowledge. Okay. All right. So, oh yeah, 1 second. This is basically the 8th question of this year. Okay. So let's have a look at the question. Okay. This question says a geometric progression. Okay. Now this has been specified. A geometric progression has a second term of 12 and a sum to infinity of 54. Find the possible values of the first term of the progression. Okay. Now please pay attention. It's a 4-mark question, so it certainly means that we'll have to do a few steps to find the value. Okay. We have two pieces of information. We know that the second term of the geometric progression is 12 and the sum to infinity is 54, and you need to find the possible values of the first term. What is the first term? How do we write first term? How do we just, what symbol do we use for it?
A.
Very good. So it's basically small a. Okay. Now, it's geometric progression. I need to recall the nth term formula because here, sorry, it's nth term. Because here they are referring to the second term, right? So nth term was basically a into r power n minus 1. This was the nth term formula. And now if I make it specifically for the second term, so when n is going to be 2, second term, so I am not sure about a, I'm not sure about r, but I know that n is basically 2, right? N is 2. So 2 minus 1. And the second term was 12. So that is given. So 12 is equal to a r. R power 2 minus 1 is going to be 1. This is going to be my first equation, and I've made this equation using whatever I had in the question. Okay, so I've used first piece of information and we are done with that. Okay, the next piece of information is that a geometric progression has sum to infinity of 54. So S infinity. So we only studied sum to infinity formula in case of geometric progression, and that was the last formula. And what was the formula? It was a divided by 1 minus r. Very good. So a divided by 1 minus r, and the sum was basically equal to 54. So 54 is equal to a divided by 1 minus r, and now I'll just take this entire thing over here, and this would give me 54 into 1 minus r equals a, and this is going to be my second equation. So now we have two equations with two unknowns, a and r, and in order to find the first term, I need to find the value of a. So it's very simple. I am supposed to solve these equations simultaneously, right? So how do we do that? Let's see. Let me just simplify this furthermore. 54 minus 54r is equal to a. Okay, so we have multiple ways. Either you can just make a the subject, it's already subject in this equation, and you can plug in the value of a, and once you plug in the value of a, you are going to get two values of r, right? Because that would make it a quadratic equation. Or what you can do is just make r the subject. So let's make r the subject, because ideally a should be the only thing, because the question is about finding a. So 54 minus a is equal to 54r, and I can divide 54 on both sides. This and this would be cancelled, and finally I would get 1 minus a divided by 54 equals r. Any confusions with this? Yes, tell me honestly, I'll wait here. Just have a look at it. I've just made r the subject from equation 2, just so I can plug in the value of r here directly, and just so I get an equation with a only, right?
Yes.
And I've just made r the subject by using simple mathematical rules, right? So basically 54 into 1 is 54, minus 54r equals a. I've taken 54r on the other side. I've divided 54 on both sides, and this would give me r. 54 by 54 is 1, and a divided by 54 is a divided by 54. Okay, so finally I'm going to plug in the values. So 12 is equal to a into r, and now I am going to write the value of r, that is 1 minus a divided by 54. So 12 is going to come as it is. A multiplied by 1 is going to give you a minus a squared divided by 54. Okay. Next, I am going to just simplify more. I'll bring everything on this side. So a squared divided by 54 minus a plus 12 is equal to 0. And now I'm just going to multiply the entire equation with 54, just so I'm able to get rid of this. So when I will do that, this 54 and this 54 would be cancelled, but not like this. Let me do it stepwise. This would become a squared minus 54a plus 12 multiplied by 54 is going to give you 648 equals 0. Now finally, it's for you, you need to do it. It's a quadratic equation. Please simplify this whatever way you're comfortable. We are already done with quadratic equations. Then tell me the two possible values of a. So I'll give you 2 minutes. Just take your time and then tell me your final answers.
Miss 18 and 36.
Okay. And Munja, please try it as well.
Okay.
Yes, Munja, are you done?
Yes, ma'am.
Okay, and what are your values?
4 and -3.
4 and -3 for A?
Yes, yeah.
Okay, let's see. Acha, so we are basically going to try doing it through factorization because I find that comparatively better. So it's A squared. Now I need two numbers such that when I add them, I get -54, and when I multiply them, I get 648. So and after thinking about it, I would be able to see that when I add 18 and 36, that gives me 54. And when I multiply the two numbers, I would get 648. So minus 18A minus 36A plus 648 is equal to 0. I'll take A common and this would give me A minus 18, and then we can just take minus common, and 36 common as well. So A minus 18 is equal to 0. This would give you A minus 36 into A minus 18 equals 0, and this would give you A equals 36 and A equals 18. So this is going to be your answer. So are you able to spot your mistake now? Hmm?
Oh, I had reduced the 54 and 60 54 and 648 maybe. That's why I made a mistake there.
So you did this by factorization?
I did reduce 54 and 64 to find the common ratio. I mean the common factor of 54 and 648.
Okay. All right, okay. So I think ideally, whatever, like everyone has their own method. If let's say using a method you were able to find two factors, just make sure that you use you just then use those numbers to see that if you add them up, if you're getting 54 or not, and if you're multiplying them, you should get 648, right? So that is a double check, just so we know that if the factors were correct or not. Okay. So this was the first part of this question. Let's talk about the next one. Okay. Again, this is coming from the same question. The question says the nth term of a progression is P plus Qn. Now, if you guys notice, the examiner has not mentioned any specific progression where P and Q are constants and Sn is the sum of the first n terms. Find an expression in terms of P, Q, and N for Sn. Okay. 1 minute. So I'll have to see. Yeah, that is for geometric progression. And here, okay. All right, okay. So the question says the nth term of a progression is P plus Qn, where P and Q are constants and Sn is the sum of the first n terms. Find an expression in terms of P, Q, and N for Sn. Okay, now forget about the arithmetic progression and geometric progression. Okay, just for 1 minute, and just analyze this thing. Just analyze P plus Qn. This is the nth term formula. Nth term formula is P plus Qn. So this means that what is going to be my first term? For first term, I can easily just plug in n equals 1, right? And that is going to give me P plus Q. Similarly, if I talk about my second term, I'm just doing this for your convenience. Second term is going to be P plus 2Q. I'm just changing the value of n according to the number of term, right? So what are we able to notice? We are able to notice that there is a fixed difference, right? The first term is P plus Q. The second term is p plus 2q. The third term is going to be p plus 3q. So what does that imply? Every time I am adding q, every time I am adding q. So this means that the common difference, or D, is basically positive q, right? And A is basically p plus q. And also it's clear that this is basically an arithmetic progression because we are adding a number time and again to get the next term. So how do we write down the sum formula in case of arithmetic progression? Sn is equal to, it's n divided by 2 multiplied by 2a plus n minus 1 into d, right? This is the formula. Everything is clear. I'm only supposed to plug in the values of a and d because the examiner wants me to write this formula in terms of p, q, and n. So Sn is equal to n divided by 2, and then 2 multiplied by, instead of a, I'll write p plus q plus n minus 1, and d is also q. So this is going to be the final answer. Yes, this is correct. And no need to simplify this, or just make it look more better. It's equally good because this is how the actual formula is even in the book. So this is fine. At times when you guys try simplifying things, some of the students in general are not able to do that, so you will just lose marks. So if it's a 3-mark question, this much working is more than enough. Okay. Yes, now you can ask the questions if you have. Yes, Rafe and Munja.
Miss, wait 1 second.
Okay, sure.
Okay, Miss, understood.
Okay, very good. Let's talk about the second part of the same question. Given that S4 is 40 and S6 is 72, find the values of P and Q. I think you guys can give it a try. Okay. Let me just stop at this point. Okay. So basically, this is the sum formula. And you have been told that when n is 4, the sum is 40. I'm sorry about these lines. Okay, when n is 4, s is 40, and when n is 6, s is 72. So you're only supposed to play with the values of sum and n. You would get two equations. You need to solve them simultaneously and then find the values of p and q. It's only a 2-mark question. Take 2 minutes and tell me your answers quickly. Okay. Yes? Anyone who's done?
Miss, we have to solve this simultaneously, right?
Yes.
Miss, then one more second.
Okay.
Miss, Q
Mhm.
is 2, right?
Yes, very good. That's right.
P squared 5.
Excellent. Very good. So this means that both of you were able to do this question. Well done. Okay. So let's talk about the next then. Okay. Now this is basically question number 3 of this exam. You can just note the details and everything.
Done, Miss.
Okay. So this is basically a 5-mark question, and it says the common ratio of a geometric progression is 0.99. Now something should come to your mind, although we did not read the question, but still. So this is a geometric progression and the common ratio is less than 1, right? So you can imagine that the if you have two terms, the next term is going to be less than the previous one, and gradually the terms are basically reducing. Their value is decreasing because r is less than 1. It's 0.99. Okay. Anyways, let's read the question. Express the sum of the first 100 terms as a percentage of the sum to infinity, giving your answer correct to two significant figures. Okay. All right. Now, let's think about it slowly first. Okay. Then it would make more sense. We know two things, that in case of geometric progression, the sum of n terms basically had this formula: a into 1 minus r power n divided by 1 minus r. This used to be the formula for n terms. Now certainly if you have a sequence where the terms are decreasing, yes, for that we can find the sum to infinity. But you can also find the sum of first 100 terms in that case. That's not an issue, right? Okay, this is the formula for n terms. And the infinity formula is basically a divided by 1 minus r. Okay, let's read the question again. So the common ratio of a geometric progression is 0.99. This means that r is basically equal to 0.99. Express the sum of the first 100 terms. So here n is going to be 100 as a percentage of the sum to infinity. Okay, giving your answer correct to two significant figures. Okay, all right. Let's do both of them separately and then we'll find the percentage as well. That is not an issue. Acha. So first of all, I am going to plug in the value. So S 100 is going to be, A would come as A because we are not sure about A. 1 minus 0.99 to the power 100 divided by 1 minus 0.99. This is the first formula. And if I talk about the next one, so S infinity is basically equal to A. A would come as it is, and it is divided by 1 minus 0.99. Now you guys would be able to spot something at this point. Okay, we do not have the value of A, but still, since we would be finding the percentage, so automatically A would get cancelled by A, right? That is not going to be an issue. Acha, okay. Now let's do this part as a percentage. Okay. Now how do we find percentages? Express the sum of the first 100 terms. Now I know that this sum would be less than this sum. Here we are adding 100 terms. Here we are adding infinite many terms, right? So Sn would be divided by S infinity. And how do we find percentage? We multiply this thing by 100%, right? This is basically the formula in general. So Sn is A multiplied by 1 minus 0.99 power 100 divided by 1 minus 0.99, and this entire thing is basically divided by A divided by 1 minus 0.99, and this is multiplied by 100%. Now A and A would get cancelled. 1 minus 0.99 and 1 minus 0.99 would get cancelled, and finally I am left with 1 minus 0.99 power 100. This thing is multiplied by 100%. So let's see what we're gonna get. Okay. When you will do 1 minus 0.99 power 100, this is going to give you 0.634. It says give your answer correct to two significant figures. So it's a good practice. If you need to give the final answer correct to two significant figures, keep your calculations till three significant figures. Now I'll multiply it by 100%, and this is going to give me 63% as my final answer. So this is going to be the final answer. Yes. Any confusions with this?
Miss the step where it is 0.634 multiplied by 100 is important, or can we just do it directly?
You were saying if you can write 0.60 directly.
I mean that if that step is important because we can just insert the values in the calculator and get 63.396%.
Yes, obviously.
Like
yeah, I
63%.
just yes, like directly from this to this, right?
Yes, miss.
Yeah, obviously you can certainly do that. I'm used to doing extra steps for some reason, but obviously you can directly just go from this step to the last one, because you won't get a separate mark for this, obviously, right?
Okay.
But I just do more working because I am afraid of getting wrong answers. That is why I'm just used to doing extra steps since the beginning. Okay, anyone else? Munja, any question?
Yeah, I understood, ma'am.
Okay, let's talk about the next one then. Yes, it's about arithmetic. It says the first term of a series is 6 and the second term is 2. So I told you, do not get confused by series. Series is just about writing the sequence with a plus sign, right? Yes, Rafe, anything that you would like to add? You were saying something.
Miss, it is the same paper or different?
Sorry. It's a different paper.
Okay, miss.
All right. So it says the first term of a series is 6 and the second term is 2. For the case where the series is an arithmetic progression, find the sum of the first 80 terms. Now it's very, very easy. I know that I've been asked to find the sum of n terms. So first of all, I'll state that Sn in case of arithmetic progression is n divided by 2, 2a plus n minus 1 into d. This is the formula. Now for this formula, I need a few things. I need the first term and I need the common difference. And I've been told that the first term is 6. So I already have the first term. I have this a. A is equal to 6. And what about d? Can anyone tell me what is going to be d?
4.
Second term.
Yes, that is
Yeah,
right. Very good.
-2.
Positive 4 or negative 4?
Negative.
Excellent. The first term is 6. Series means they're writing down the terms with plus, and second one is 2. And you know that it's arithmetic. So I'm going from 6 to 2 by negative 4, right? By minusing 4, by subtracting 4. So D is going to be negative 4. Now I have everything. Sum of first 80 terms is going to be 80 divided by 2. And then 2 would be multiplied by the first term, that is 6 plus 80 minus 1 into d, that is negative 4, and this would give you 40 into 12 minus, again you can just do it directly as well. This is how I do it for some reason. Then it's 79 multiplied by negative 4, and I'll finally write down the answer. It's going to be 12 minus 4 into 79, and this thing is multiplied by 40. So it's negative 12,160. This is going to be the answer. Now you can clearly see that the question was about finding sum of first 80 terms and the final answer is negative. So you can certainly have a negative answer if you have negative terms. Obviously, when you will add negative terms, you would get a negative answer. Okay. Yes. Is it fine?
Miss, eventually we write the answer in like 3 significant figures. So we'll write -12200, right?
No, 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 no. No, basically, I'll tell you. If the examiner has mentioned in a question specifically, in that case, we'll round it off. I agree that in the beginning of the question, this stuff is mentioned that give your answer correct to that or that. That is good as long as you are getting something in decimals, right? If you're getting something in decimals, then you can round it off. If you're getting a solid figure, please never ever round that off. This is going to be your final answer. If you write your final answer as 12,200, that is not going to be correct because this is something that has to be exact. It's sum. Okay, it's not coming in decimals or stuff like that. In case of decimals, it's fine if you give your final answer up to 3 significant figures, but otherwise not. And in the previous question, the examiner mentioned that in the statement of the question. So that is why we made sure, but not for such questions, not at all.
Okay, miss.
Okay. Acha. We have 1 minute, I suppose. Let's do the second part as well. For the case where the series is a geometric progression, find the sum to infinity. S infinity is a divided by 1 minus r, but this was not the challenge. The challenge was to find a and r. So the first term was basically 6 and the second term is 2. 6 and second term is 2. I'm going from 6 to 2 by multiplying 1 by 3. This means a is equal to 6 and r is equal to 1 by 3. So that is it. 6 divided by 1 minus 1 by 3 is going to give me the final answer, and that is going to be 9. So this is going to be my answer. Okay, so here I was again supposed to find a and r is basically the common ratio. It's basically the number I multiply with the first one to get the second one. That's 1 by 3, and this is how I get the answer. Yes, any confusions with this?
No, miss.
Munja, what about you?
No, miss. Thank you.
Okay, all right. Then let me stop the recording.